Good morning to all. I am Subharani, Associate Professor, Emmanuel Arasa College of Pharmacy. Today's topic is fat and oils. The introduction. Fat and oils are the most abundant liquids in nature. They provide energy for living organisms, insulate body organs, and transport fat-soluble vitamins through the blood. Fat and oils are the most abundant lipids in nature. Any of a group of natural esters of glycerol and various fatty acids which are solid at room temperature and are the main constituent of animal and vegetable fat. The natural ester of glycerol and various fatty acids which are solid at the temperature in room temperature and are the main constituent of the fats in animal and vegetable. Next, types of fats. There are two types. First one, vegetable fat and animal fat. Vegetable fat. Vegetable oils or vegetable fats or oils extracted from seeds or from other parts of the fruits. The vegetable oils are vegetable fats extracted from the seeds or other parts of the fruits. Like animal fats, vegetable fats are mixtures of triglycerides. Animal fats and vegetable fats are the mixture of triglycerides. Next one, animal fat. Animal fats and oils are lipids derived from animals. Oils are liquid at room temperature and fats are solid. Chemically, both fats and oils are composed of triglycerides. Vegetable oils or vegetable fats are extracted from seeds and other parts of the fruits. Then animal fats and oils are lipids. They derived from animals. Oils are liquid at room temperature and fat are solid at room temperature. Chemically, both fats and oils are composed of triglycerides. Differentiation between fats and oils. Fats are solids or semi-solids at room temperature. Fats are sometimes solids or semi-solids at room temperature. Oils are liquids at room temperature. Oils are already liquids at room temperature. Fats contains large amount of saturated fatty acids, but oils contains large amount of unsaturated fatty acids. Fats contains large amount of saturated fatty acids, but oils contains unsaturated fatty acids. Some examples of saturated fatty acids are stearic acid and palmitic acids. Then oil contains large amount of unsaturated fatty acid. The fatty acids are oleic acid. The next point, fats melt at high temperature but oils melt at low temperature. Then fats do not contain double bonds, the oils contains double bond. Okay, so four different differentiation. First one is fats are soluble or semi solids or semi solid, oils are liquids. Fats contains large amount of saturated fatty acid, oils contains large amount of unsaturated fatty acids. Fats melt at high temperature, oil melt at low temperature. Fats do not contain double bonds, but oils have double bonds. The structure of fats and oils. Fats and oils are called as triglycerides. Fats and oils are called as triglyceride. The glycerol is reacted with three same or different fatty acids in the presence of a catalyst to form triglyceride. Glycerol is reacted with three same or different fatty acids in the presence of a catalyst to form triglyceride. Classification. The classification of fatty acids. It can be mainly classified on the basis of carbon-carbon double bond and carbon chain length and dietary needs and structure. First of all, carbon-carbon double bond. The fatty acids are divided into three types: saturated, monounsaturated, and polyunsaturated. On the basis of carbon chain length, short, medium, long, very long fatty acids. Short fatty acids, medium, long, very long fatty acids. Dietary need, it is two types: essential fatty acids and non-essential fatty acids. Structure. On the basis of structure, it is straight chain, branched, cyclic, substituted. So the classification based on four methods: carbon-carbon double bonds, carbon chain length, and dietary need. Then last one, structure. First one, saturated and unsaturated fatty acids. If the hydrocarbon chain of the fatty acid contains no double bond, it is termed saturated fatty acids, since there is no room for any more bonding. If the hydrocarbon contains the fatty acids, no double bond is termed as saturated fatty acids. If the hydrocarbon chain of the fatty acid contains one or more double bonds, it is termed as unsaturated fatty acids. So the fatty acid contains no double bond, saturated. The fatty acid contains one or more double bonds present. It is known as unsaturated fatty acids. Mono and polyunsaturated fatty acid. The unsaturated fatty acid is divided into two types. First one is monounsaturated fatty acids and polyunsaturated fatty acids. Monounsaturated fatty acid means the fatty acids with one double bond are called as monounsaturated fatty acid. Fatty acids with one double bond are called monounsaturated fatty acid. The fatty acids with two or more double bonds are called as polyunsaturated fatty acids. Mono and polyunsaturated fatty acids. Monounsaturated fatty acids contains one double bond in fatty acids. The polyunsaturated fatty acids contains the fatty acids with two or more double bonds. Next basis of classification, length of hydrocarbon chain. Short chain fatty acids contains less than 6 carbon in the hydrocarbon chain. Less than 6 carbon, short chain. Medium chain fatty acids contain 8 to 14 carbon atom present. The long chain fatty acid contain 16 to 24 carbons in the hydrocarbon chain. Very long chain fatty acid contains above 24 carbon atoms. So short chain fatty acid contains 6 carbon. Medium chain fatty acid contains 8 to 14 carbons. Long chain 16 to 24. Very long chain fatty acids contains above 24 carbons. The melting temperature of the fatty acid increases with the addition of carbon atoms to the hydrocarbon chain. Addition of carbon atom to the hydrocarbon chain, so the melting temperature of fatty acid will be increases. Then essential and non-essential fatty acids. Essential fatty acids are not synthesized by the body, hence they must be only obtained from dietary sources. For example, linoleic acid is the precursor of omega-3 arachidonic acid. So essential fatty acids not synthesized in the body, but they are only obtained from dietary sources. Non-essential fatty acids are synthesized by a healthy body as long it gets enough essential fatty acids. So non-essential fatty acids are synthesized by healthy body as long it gets enough essential fatty acids. Next, nomenclature of fatty acids. The systematic nomenclature of fatty acid is based on the hydrocarbon. It is hydrocarbon. The names of the saturated fatty acids end with suffix anoic. The names of the saturated fatty acids which contains the suffix anoic. Example, octanoic acid. Whereas an unsaturated fatty acid's name ends with suffix enoic. Example, octodecanoic acid. So, saturated fatty acid contains suffix anoic. Unsaturated fatty acid contains suffix enoic. The numbering of carbon atom begins from its carboxyl carbon. Hence, the carboxyl carbon is given the number 1. The adjacent carbon atoms are numbered 2, 3, 4. The second, third, and fourth carbons are also referred to as alpha, beta, and gamma. The terminal carbon atoms on the other and containing the methyl group is referred to as omega carbon. The terminal carbon atom on the other end containing the methyl groups are referred to as omega carbon. The carbon atoms are alternatively numbered from omega carbon omega carbon side as omega 1, omega 2, omega 3, omega 4, etc. Then physical properties of fats and oils. Pure fats and oils are colorless, odorless, and tasteless. The fat and oils are colorless, odorless, and tasteless. Fats and oils are lighter than water, having the density of fat and oil is 0.8 gram per centimeter cube. Fat and oils are poor conductor of heat and electricity and therefore serve as excellent insulator for the body, slowing the loss of heat through the skin as less. So the physical properties are fat and oils are colorless, odorless, and tasteless. It is lighter than water, having density of about 0.8 gram per centimeter cube. They are poor conductors of heat and electricity. Chemical properties. Chemical properties including hydrolysis, hydrogenation, saponification. First of all, hydrolysis. Breaking down into glycerol and fatty acids. The oil and fats are hydrolysis to give breaking down into glycerol and fatty acids. Hydrogenation. The fat and oils are adding hydrogen to make oils solid. Saponification. React with alkali to form soap. They undergo oxidation, means rancidity. They undergo oxidation, developing of flavors, and their melting points depend on fatty acid saturation. Hydrolysis by acid. The mineral acid causes hydrolysis of fats. For this mixture of sulfonic acids, which are obtained by sulfonation of mixture of oleic acid and benzene. The above three ways give glycerol and fatty acid as the product of hydrolysis of fats, while alkaline hydrolysis of fats gives glycerol and soap, which are used as cleansing agent. Then chemical properties of fats and oils, that is hydrolysis. Triglycerides are easily hydrolyzed by enzyme called the enzyme is lipase into fatty acid and glycerol. Triglyceride easily hydrolyzed in the presence of enzyme lipase to form fatty acids and glycerol. Then uses of fats and oils. They are energy reservoirs and are more effective proteins and carbohydrates. They are effective reservoirs and are more efficient proteins and carbohydrates. They are used in soap industries. They are used as raw materials for preparing higher alcohols, used for manufacturing synthetic detergents. Groundnut oils are used for manufacturing vanaspati ghee instead of dalda, rat, gagan, etc. Castor and cotton seed oils are used for purgatives. Cod liver oils are used in vitamin A and vitamin D deficiency conditions. They provide excellent insulation since fat is bad conductor of heat. Derived lipids are important building blocks of biologically active materials.